start down bottom, and if it's up top, you start up the top. So that was not what Ingrid would have taught you to do right there. I like, have they done an assumed level? No, but they haven't done an outlet structure either. Outlet structure's missing, just the pipe going into the water. Most other things are pretty good, but there's no grade on there. Now remember, the grade is only shown where the knife cuts through the pipe, or the cross section cuts through the pipe, to where the end of the dash lines are. So if the pipe's going on that angle and you cut through it, but you can still see pipe in the ground in the distance, that's the bit you grade, not that the whole pipe. So it's talking about multiple cross sections which you're going to be doing for your assignment. I'll do one in class, and then if there's time I might show you I'll show you the only thing you need to do in terms of your volumes. In fact, I think I will go through and do that. Oh no, that's next week on the volumes. But I'll show you how to do what I call a line drawing or a stick drawing of the cross sections and how many of those I'm expecting you to do. Now, with cross sections, often the survey company will provide you with the cross sections. So as an engineer and a young engineer in the office, your job from your senior engineer will be something like, can you get hold of the survey company and give them a brief on what to do, where to go, and what you actually want them to supply. Now the obvious thing is you want an AutoCAD drawing supplied, but you also need to tell them the intervals for the contours, and you need to show them where exactly you want your cross sections taken. My experience with surveying companies, Dave Pointer and I have a bit of a banter from time to time if you're in the field when you see us. He thinks I hate surveys. I don't hate surveys. It's just that over the years, some of them have provided some pretty just terrible data for us to do our design on. And the thing is that in my capacity in consultancy, I used to have to quote for the jobs. And if I've quoted my team, 5 hours each or 10 hours each to finish the job, and we spend the first day fixing up the survey plan, which is we've done before, we've lost all that time that we can't really charge the client. Because we've already charged them for the survey, they've given us the survey, and we paid for it. So it became quite important to write a good brief on what exactly you want from the survey company. I guess if you write a crappy brief, you're going to get a crappy file out of the whole thing. And the other thing is the surveyors are often the ones that are on site. So they go out on site, for the day to do the survey, but they're your eyes and ears. So don't be shy to say to them, hey, can you check while you're on site that they've done that excavation down one end, down the south end, or can you see if the diggers have left site or they're still around? Things like that. Save you a lot of money, especially in driving time around Auckland and what have you to go and see jobs. Then there's the extent of the survey. Things have changed a lot over the years. I remember when they used to do flyovers over Auckland and take photos, and they were able to, this is quite like early technology in the 80s and 90s, they were able to put contours on those photographs, which I thought was really cool. So we would buy that digital data and we would have contours on the data, and we'd bring it into AutoCAD, and I'd say, look at that, we've got contours already for such and such an area. But as things have become more and more advanced, satellite has come into play and changed the way we think about everything. We can get contours in satellite down to 0.5 of a metre now, even less. So when we quote on massive jobs like the motorway extension that's going to go from Warkworth to Wellsford, we can get it pretty accurate in terms of earthworks and all the rest. One of the things that used to stuff us up, though, is still stuffing us up, is areas where you have a lot of trees. You can do an average for the trees or the bush, 2 metres high, 3 metres high, and work it out that way, but that's averages always come back to bite you in the backside when it comes to the reality of what jobs cost. We also, in my time, I did a lot of shape corrections on roads. So we used to only require a level, a tape and a staff, and we'd head off and do our cross sections through the bit of roading that we were shape correcting. When you shape correct the road, when you go around a corner in a car and there's a bit of camber on the road to stop you from running off it. Well, as big trucks and that go over the road many, many times, that bit there flattens off. And that often causes accidents, especially the likes of boy racers who aren't that experienced and they try to take the corner at a higher speed than they should. And because it hasn't got the camber on there, the car just straight off the road. So a lot of my work in the early days was shape correction. So we do a small portion of the road, we do cross sections, work out the earthworks and the cost of it, and then redesign it so they had a lovely curve going around, and then they'd retar seal it in the end. We didn't actually use surveyors for that sort of work. We tended to go out and do, engineers would tend to go out and do the work themselves. And that's why you do surveying here at Unity. We don't just leave it all to the surveyors. However, if you're doing a motorway, it would be a different story, because that's got to be accurate to, sort of almost 10 or 20 mil. So you need a registered surveyor to go out and survey the land properly and verify every step of the motorway. There's a section on scales, the scales you should do the cross sections, and on the slope. The slopes coming down from the roads or from a platform. Unfortunately, this is where I've done a lot of jobs with the geotechnical engineers, not really being my best friend either, because grand generalisation, they tend to be fairly scruffy with beards, and they sit in the corner at work and they just seem to dream up numbers for slick down slopes and those numbers don't sort of bear relative to anything that I've worked out or that I can see, but they are the boss, they're the registered geotechnical engineers, so if they say 2 to 1 or 3 to 1 or 1.5 to 1, that's what it is. And it's all done on the soils versus the strengths. You will do a little bit of that in your study here, work out the strengths of things. There's also a fine line between a structural engineer and a geotechnical engineer. A lot of structural engineers will actually go on and get qualified as geotechnical engineers as well, so they don't have to actually deal with them, because they can then design their own foundations for buildings. My issue is that I've done a lot of jobs where I've balanced the cut and fill perfectly along the road. So we use that bit of cut, put it there, use that bit of cut, put it there. Okay, we need some more fill over there, so you cut that bit, and it would end up being, hardly anything to bring on site or take off site. And that's the perfect design. I mean, that is big pat on your own shoulder for doing that. And it's really hard to do that, and especially when the geotechnical engineer suddenly wakes up and says, actually I changed my mind, it's not 1.5 to 1, let's make it 1 3/4 to 1. And he'll go back to his desk again and go back to sleep. Well, at that point you're just about pulling your hair out, because you've already produced 40 or 50 drawings along the road. You've done your quantities and you've got to rebalance it all again. So, unfortunately, they rule the roost on the batter slopes. What they don't rule the roost on is the heights of the road, the vertical height of the road. So you can get around them by a small shift in the vertical height. You can also get around them by something called benching, which is in the test, and it's worded very much like, how can you make a steeper slope without involving the geotechnical engineers. I guess from an engineering point of view, from a diploma in engineering, all you really need to know is that the batter slopes are worked out according to the material that's in the ground, and it varies accordingly. Here's some examples. And rock would have probably one of the steepest batter slopes you can have, right down to something that's got sandy silt in it, which pretty much is very difficult to have a batter slope. I've included some descriptions here, which are good tucker for a test. Alright, so highlight that page. I'm thinking seriously, it's probably going to be an open book test. So if you've got your notes and you've highlighted various sections, it might be quicker to go back to that to see things. This is not going to be a test on who's the quickest to Google things, or who's the quickest to find things in the notes. It's a test where the people that know the answers are going to power through it at 100 kilometres an hour and have enough time to check some of their maths at the end. Or if you try and Google it, you're going to be 2 or 3 questions short at the end, because you won't get the time. So it's off the top of my head, it's a 40-minute test, which makes 2 minutes per question. So you are going pretty quickly. Some students that English is their second language struggle with the multi-choice. They take forever to decide A, B, C, D, and they power through the maths one so quickly that they've got a wee bit more time up their sleeve, but others are the opposite. So anyway, I definitely highlight that area there. We've talked about formation levels. Benchmarks are things that are put on site so that the surveyors can set up their instruments and carry on working out the levels. Often they use, or they start with a manhole which is known by the council, the local council, so they can work back and use council levels. You know, when you're doing the surveying and you ended up with the reduced level at the end as you went round, I think you had to go around the building here. Usually that's your first thing. I sit there laughing as you're going around 9 times before you get it right. I think the record was 9. The guy's not here anymore now, didn't actually pass engineering for some reason. But yeah, that reduced level is really important when it comes to cross sections. And it's really important to get those levels 100% right, and that's why we put you through the ringer when you first come here at Unitec, or David does, not me, blame him. So when you're building up a road surface or a platform, but normally a road, we have something called the sub-base, and we have our original cut goes down to clay, and then we start putting on the sub-base, then the sub-grade, and eventually we put on the bitumen after that. There's a good example of benching. How we cut like this when we bench, and it often allows us to do a steeper slope than the slope that the surveyors asked for. It's the same drawing again there, and a checklist. Have you shown a datum line for your cross section? Well, that was on the long section, the datum line. Have you dimensioned the platform on the cross section? Have you done it on your long section? You don't actually have to show dimensions. You can, if you want, do an arrow with the dimension in each way, 10 metres by 10 metres. Remember, on your existing site plan, the platform is a proposed platform. On your proposed plan, it is also proposed, but it will become a thick line. You've got a survey line at the moment between pegs. Peg, survey, traverse. Have you shown levels for the existing ground? Have you shown levels for the design plan? What I was talking about before, have you extended the cross section to pick up enough of the features like trees, swamps, path, etc.? Provide all cut and fill for all areas that are relevant, and change of the distance measured from one end, so that's a continuous distance. Subdivisions. Every area in Auckland will have its own code and its own standards for subdivisions. It seems that places like Mount Albert here falls into the zone of being able to pack as many houses as you can into the one section, and you can go as many as 3 stories high. As you get out into the burbs, Henderson and what have you, Ranui, the rules are quite a bit different. You have a minimum lot size, and that's usually quite a bit higher than that. And I do note that up towards my way, you've got Milldale and Mill something or other. those subdivisions have also got different rules attached to them as well. I think the issue is that the unitary plan for Auckland is always changing. One council gets in and they say, okay, we're in the city now, we can build 8 stories high and so much wide and all the rest, and the minimum size for apartments, squeezing you in like boxes. And then another one will get in and say, no, we don't want that anymore. We want this, that, and the next thing. So the unitary plan is usually the first thing you check out, plus any of the restrictions, like how far from the street you can build and all that sort of thing. For a lot of that work, we need cross sections, so we can work out heights to boundaries and things like that. And daylighting they call it. We also need to work out whether it's residential, industrial or commercial. And each one of those zones has different rules as well for building. So this goes into detail of the developer and the developer's responsibilities, and then the consenting authority who hand out the consent for the development to go ahead. Sometimes there's a bit of a conflict of interest. These kangaroo houses that they're building here and they're building down Carrington Road, the Labor government wanted them to be built as quickly as possible so that it looked like they were building or being able to build lots of houses quickly, because people drive down Carrington Road and they see houses being built. But it turns out that that decision was probably a pretty poor one, because long term building there first is creating all sorts of issues on Carrington Road. It's a very busy road. They would have been better off building further back and moving towards the road at the end. So it's an example of bad engineering design, but the design might have been alright, but it's a bad concept to try and build the ones along the road first. I'm not sure which ones are going to get built here first. There's 2 rows of them, and some of them are 4 high. So it's going to be an interesting concept when they're all occupied. Parking's going to be interesting as well. So generally speaking, there's the developer will go to and from the local council, trying to figure out what they can and can't do before they start a development up. And then there's a design process where they're to and fro with the client on the best design. And also when you're designing, you've got to take into account the water, the drainage, the sewage, the stormwater. A lot of other things come into play with development design. What I'd like to go back to, seeing as you've all got a hand in coming up, the platform pipe long section. Just want to go over a checklist for that from last week, because a lot of you have started it now, according to my video, and been drawing it up. As you're going through this project, you'll be noting things that are of a bit of concern. One of them I would suggest will be the tree. One of the trees is in a position where it might have to be cut down. Another is engineering concerns during construction. It's pretty close to Unitec. Students getting too close. Noise, sound, dust. And generally just the order that you're doing things in, bringing the fences in first up, and access, site access, where you're going to put your site up and all the rest. Make sure you show the invert levels at both ends of the pipe. And there's another thing where the pipe ends. I drew this on the board last week, but a lot of people didn't quite understand it. So you've got a point where the pipe ends here, right? Now, your manhole goes around like this. That's 100 mil thick, 0.1, and that radius of the manhole is from there to there is 1.050. You can't put your lid there, so the lid can go anywhere from here around to there. So I'm just going to put it there, and that's 0.6. And you'll find somewhere around about here is where your ground line is going to go in plan view. The pipe's way down the bottom, but this manhole should protrude. Actually, goes through there like that, doesn't it? The manhole should protrude in by 100. And at the other end, I gave you the dimensions for this. There's the survey point there, across. It's the survey point. Don't cut the pipe off. Build the structure around the pipe. Like that. That's the outlet structure. Those distances I gave you a couple of weeks back. Remember that the pipe will have a centre line on it and a certain line type around the outside. So will that. Because on the existing site plan, all of this is proposed. Hasn't actually got there yet. When I said on the long section, the grades of the pipe, you want to put your arrow, your triangles as close as you can, and call the numbers up. Don't make the numbers little, make them the 0.35 text size.
All numbers 0.3.
Yeah, the only things it won't be is when you have, say, the word legend, and then, you know, you might have the swamp, and you might have a manhole or something. You might have the pipelines.
So the titles are 0.
So the titles that are in that box would be 0.5 here. But any notes pertaining to these things would be 0.35. Yeah. Same with the survey coordinates. You might have the word survey coordinate table at 0.5, but the survey coordinates will be 0.35 here. We're going to talk briefly at some stage next week about the proposed site plan, which is part of assignment 2. And some things will be able to be copied from your existing site plan, but some things will be different. So your pipeline on your proposed will be solid, but it's in the ground, so therefore it'll be dashed again. And you always show the centre line of the pipe in plan view, so the centre line will be there. With proposed, I guess some things will be different. There might be some more notes on there as well on your proposed plan. And I'm going to get you to draw some water flow arrows on there too, and I'll talk about that when the time comes. We've still got a few more weeks to go in the semester before half of the semester for me to get all this information to you. The other checklist was on further back here when it came to checklist here in terms of notes. General note, engineers to check on site for. Environmental engineering note, now that would be to do with the wetlands, the perk echoes. Contractor general notes before commencement of work, contractor to check, well I would say check drawings and verify dimensions before you start any work. Local body notes and Auckland traffic notes. A full cone design would be required for traffic control. Local council notes would be contractor's responsibility to for noise and for clay on the machines. So what you don't want is on the trucks, you don't want them driving off down Carrington Road and all sorts of clay being left all the way along the road. They usually at washing down stations anyway, but you've imported the title block into A1. I showed you last week how to bring the long section into that title block. Yep.
What is the dimension for the flag?
For the
Flag.
The platform, there's a flag, section flag.
oh yeah. What did Ingrid say? 3:1.
She said like it has to be like vertically high, the bottom it should be small.
So something like this. Well, proportionally 2:1. 2:1. I'll make it 3:1 actually. 3:1. Sounds about right. I'll just playing football with my market here. 3:1 would be a reasonable target. So 3:1. Don't make it 3 millimetres to 1 or 3 metres to 1. Just use that portion. So, as an idea, if it's a flag, can I ask you why you're putting a flag in?
We don't have the processing yet. We don't have the processing yet, so why we put the...
you would put the flag on the proposed plan for your cross sections. The proposed plan is assignment 2. So I'm assuming you're quite a long way here.
Just give me. Okay, so
He's already working on assignment 2.
Is he? Goodness
nah,
me.
nah, nah.
I tell you what, if you want to show me a flag you've drawn, I'm happy to, before assignment 2 handed, I'm happy to say yes or no to a length.
So
It was a bit easier with Ingrid
if we
because it
do
was
that,
a.
can you give us 0.5?
I'm giving you a proportion, 3:1. So that doesn't mean I'm giving you a length. Yeah, show me your work during the lab. Show me a flag example as that proportion, and we'll have a look at it from you. 3:1, 1 metre by 3 is huge. So it'll be point something by point something. Yeah. So the hardest part about the assignment is to come up with some engineering, environmental, and water engineering notes. But if you have a look at some of the plan examples, there's already some notes on there, and it isn't that difficult to work out, say, a local body note. Look up Auckland City Council, look up consents, or applying for consent. I would say what they would be worried about would be siltation going into the water, traffic control, and whether or not, what are you doing with your trucks? Are you washing them down, or are they taken off along Carrington Road with dirt on them? So, are there any questions on what we're doing in terms of the long section and the plan?
Could you tell us the dimension of the PP outlet?
Of the outlet, I did that 2 weeks ago, and I can't remember what I told you. I'm pretty sure it was a metre either side of the pipe, but I don't want to put my hand up for that. So I'm pretty sure I did. Has anyone drawn it yet? Well, if someone's drawn it, then that'll be the dimension. If no one's drawn it, then I'll do what I think I told you. Remember, this pipe is 450, so it's quite a big pipe. So you are going to probably need a slightly longer. Like we're running out of juice here, I might have to go and get another pee. Yeah. I'm pretty sure it was 1 metre. What do you think? Okay, can I tell her that for a second and then reduce it? Is that? 1 metre? Yes. Yes. Just getting around for it. Could be more fit. No, I've found one. All right. Thanks to this lady here. Thank you very much. Yeah. Okay. So this is what I did on reward. Get rid of that. 1, 3, 4, 8. 1, 3, 4, 8. Yeah. So 1350, this angle is 45 degrees. So looking down on it, that angle there is 45. Okay? And it pokes in by 100. That pipe pokes into it by 100. That's 450, 450, 450 right the way around here. Remember the pipe's 450. But that height will vary according to the ground line. So when your ground line comes down, that distance there is 100. And it can either go like this, or it can go like this. It's flat side. That's more common. If the wall's the same height here as it is there. Yeah, I didn't take a photo of it myself, so I was a bit worried that I was going to give you the wrong information. Here we are.
For the cut and fill, the the fill one should be the dashed line, right? For the long section?
For the cut and fill,
Yep. The line type of the
for the cross section or the long section.
long section.
So we've got Lucia coming in soon, so we should. So for the cut and the fill, what are you talking about? The dash line. So here's your ground line. There's your cut and fill. Which line should be dashed?
The fill one should be dashed, right?
The fill, this one.
Yep. Oh, that one, the ground one, not the triangle one.
Not that one. So that dashed as well. Is that what you're saying?
No, I say like the triangle one should be the dashed line, right? Yeah, that one should be dashed line.
This?
Yeah.
No,
No.
because it's a long section, so it's showing the proposed. It's showing it as proposed. That is dashed because.
Continuous.
So it's a journey we're going on where we're going to probably find there's a tree in the road, or the fill's going to go into the tree. So we're going to have to do something about it. Add some more notes. All right.
Even hatch, you write in your notes, the hatch is one long line and one short line and one long line.
The hatch,
Similar different.
the hatch in here
Yeah.
No, what I said in my notes is that if you want to do a hatch like that, that's wrong. If you want to do a hatch like this, that's wrong. If you want to do a hatch like this, that's wrong. If you want to do a hatch like this, that's wrong. So you have to pick a hatch that is correct. Sand, concrete, rock conglomerate, and I've already said that's the building.
Yeah.
Hello?
I'll make a complaint.
Oh, it's right on 10:30.
I'll make a complaint.